Hey guys, so today we're going to be talking about exponential growth and decay word problems. So if you remember from a few weeks ago, we talked about our exponential decay formula and we use f of x equals ab to the x, where a is our initial value or our y-intercept and b is our growth or decay factor. What's going to happen now is your situation is going to be either going up by a percentage or going down by a percentage, in which we're going to be using this formula here. Okay, they may also use t, so I'm going to actually put f of t equals a times 1 plus r to the t. Okay, so what's going to happen is if I'm using exponential growth, I'm going to have 1 plus r. But if I'm using exponential decay, I'm going to have that same formula, but I'm going to have 1 minus r to the t. Okay, so my plan is to look at the odd examples, and then I'm going to let you do the even examples on your own. So number one, find a bank account balance if the account starts with $100, has an annual rate of 4%, and the money left in the account is left in the account for 12 years. Okay, so if you know anything about having a bank account, you know that bank accounts will acquire interest after a certain time. So if you have an account that starts at $100 and you just let that $100 sit there, it is going to accumulate some interest, which is why you want to have a bank account. Okay, so I still want my starting point, which is my A equals. So I'm starting with $100, so that's going to be my y-intercept or my starting value. Then instead of B equals, I'm going to have R equals because I want to talk about that rate. So it has an annual rate of 4%. So that's going to be my R. But when I write my R, I'm going to write it as a decimal. So it'll be 0.04. If you remember, all you do when you have percentages and turn them to decimals, you just move it over twice to the left, and that's your number. Okay. So now that I have my A and my R, I'm just going to plug them in respectively. Okay. Now, I do want to know, is this situation exponential growth or decay? Since this account is going to increase, they're not going to just take these people's money away. This is an increasing situation, so this is going to be exponential growth. So when I write my equation, I'm going to have f of t equals 100 times 1 plus 0.04 to the t power. Okay, or they may actually add that part in parentheses. So if I add 1 plus 0.04, that'll give me 1.04 to the t. Okay, so that's my equation. Then after I get my equation, they ask me a question. They want to know how much will be in account after 12 years. So if this money just sits in this account for 12 years, how much would it grow to? So what will happen is this is our t. So t equals 12. I'm going to take this 12 and I'm going to plug it in for t. Okay. So you can use your calculator. You can use decimals, whatever works for you. I'm going to use decimals. So I'll just type in 100, open parentheses, 1.04. And this is to the 20th or to the 12th power, okay, because I want 12 years. And as we see, that is worth $160.10. Notice I'm rounding it off to the nearest hundredth because we're talking about money. So we're going to write that out. And I do want you to write a sentence, so I'm going to put after 12 years, there is $160.10 in the account. All right, and that's it. All right, let's look at number 3. It says Melanie bought a used car for $16,000. The car dealer said the value of the car will decrease to 12% the first year and will continue to depreciate in a value of 12% of its value each year. Okay, So one thing we know about cars is once you buy them, once you drive a car out the lot, that value does decrease. They have a word depreciate. All depreciate means is that it's going to lose value. So she bought the car for $16,000. So what that means is A equals 16,000. Then they said it will decrease. So we know that this represents exponential decay. And my R is going to be 12%, which I'm going to change that to a decimal, so I have 0.12. Since it's exponential decay this time, I'm going to be using my 1 minus R. So I'm going to have f of t equals 16,000 times 1 minus 0.12 to the t. Okay, or as I said before, they may actually write out or subtract out that number. So I have 16,000 times 0.88 to the t. Okay, so they didn't put this on here, but let's say they wanted to know the value of the car after 5 years. What I would do is I would take 5 and I'll plug it in for t. Okay, so let's do that in the calculator. So I have my 16,000. I have my 0.88. And we're raising that to the 5th power. Okay. So as you see, this account or this car will be worth $8,443.71. Okay. So if this person wants to sell this car, that's about how much they're going to get 5 years later. Okay. All right. Let's look at number 5. Okay, you inherited land that was purchased for $30,000 in 1960. The value of the land increased by approximately 5% per year. What is the approximate value of the land in the year 2011? Okay. So many people get land all the time. This is probably one of the greatest assets you want in life. So they purchased it for this amount. So that's going to be my A. That's my starting point. Okay. Then my R, again, is going to be my rate. It says it's increasing, so we know that this is exponential growth. And it's increasing at 5%. So I have R as 0.05. So when I write my equation, I'm going to have f of t equals 30,000. Since it's growth, I'm going to have 1 plus 0.05 to the t. So this is my equation. Now here's one part that may be tricky. I want to know how much the land is in 2011. Make sure you subtract that by 1960, because you can't just put 2011 in for X. Okay, so I want to think about how many years is it from 2011 to 1960. Okay, you want to think about that. Okay, and that'll be 50 years. So I know that my X is going to be 51 years. Okay, yeah, 51, sorry. Okay, so I would take 51 and I would plug it in for t. I type in my equation, so 30,000 times, what was it again? We got 1 plus 0.05. Okay, and this is how much this land is now, and it gained a lot over time. Okay, so this piece of land will actually be 361,000. $223.09. Okay, so as you see with exponential functions, they grow really, really fast. So yeah. All right, let's move on to our last one, number 7, and I'm gonna let you guys work. Okay, it says you buy a new computer for $2,100. The computer decreases by 50% annually. When will the computer have a value of $600? Okay, so my A, again, is my starting point. So A is 2,100. It's decreasing, so I know that this is going to be decay. And it's decreasing by 50%, so that's going to be 0.05 for my R. So I'm going to have F of T equals 21,000 times 1 minus 0.50 to the T. Okay, now the tricky part about this one is they're asking me when. So that means I actually want to find T. Okay, which means I'm going to have to substitute in this 600 in for my Y. So it's a little different. So what I'm going to do to get that answer is I'm going to go to Desmos and I'm going to type in my equation. Okay, now that I have my equation in, and I'm gonna set this as let's set this as a function so that the calculator knows that this is a function. So I'm gonna put f of x. I'm not gonna use t because I'm not sure if the calculator recognizes that. And what I'll do is I'll put this to the x. Okay, so now I have a graph of what's going on. So I'm gonna look for where is this gonna be that amount that they asked for. So I'm gonna go here and I'm gonna see if I can get a table of values. And what I'm looking for is when will it be 600? Now it's not gonna be exactly 600 on a table, but we know that 600 falls between this 12, between 1 and 2 here. Okay, so I'm gonna just say that the computer will be $600 between 1 and 2 years. Okay, so somewhere between there, that will be the amount that the computer is worth. So I'm going to put in 1 to 2 years, the computer will be worth $600.